Hello and welcome. Here we are going to discuss about fermented dairy products, their production, nutritional and therapeutic properties. The objectives of this lecture are to provide general introduction to fermented dairy products, to acquaint the students about the health promoting effects of fermented dairy products, to acquaint the students about the production of technologies involved in the production of different fermented dairy products. Milk is the normal mammary secretion of milking animals obtained from one or more milkings without either addition to it or extraction from it, intended for consumption as liquid milk or for further processing. Milk is highly perishable and many methods have been developed to preserve it. The earliest method, which has been used for many thousand years, is fermentation. Milk can be fermented by inoculating fresh milk with the appropriate bacteria and keeping it at a temperature which favors bacterial growth. As the bacteria grow, they convert milk sugar, that is lactose, to lactic acid. The lower pH caused by the lactic acid preserves the milk by preventing the growth of the putrefactive and or pathogenic bacteria, which do not grow well in acid conditions. Biochemically, fermentation is defined as the catabolism of glucose or other sugars in which the terminal hydrogen acceptor is an organic carbon-containing molecule. During the breakdown of sugar, known as glycolysis, excess hydrogen atoms are generated and must be deposited somewhere. In lactic acid bacteria, they dump excess hydrogen on the pyruvic acid, the end product of glucose. This turns pyruvic acid into lactic acid. In all fermentation, NADH gives up its hydrogen to produce NAD positive, which is required for further glycolysis. Yeasts too perform fermentation but with different terminal hydrogen acceptors, that is, acetaldehyde and products like carbon dioxide and ethanol. Alcoholic fermentation is also an anaerobic process since the terminal hydrogen acceptor in each of these microbiological processes is an organic molecule. They are, by definition, thus fermentation. Fermented dairy products can be produced via fermentation of lactose by microorganisms naturally found in milk. These are made from milk of almost all domesticated milch animals. These products are popular due to their differences in taste and their favorable physiological effects. There are two main species of bacteria that are involved in fermentation. These are lactic acid bacteria and bifidobacteria. The fermented dairy products feature a number of advantages. They offer a high degree of hygienic safety. They have an increased shelf life compared to the raw product. Their manufacturing requires only basic technology and low energy consumption. They meet a demand for natural and organic foods. Now the cultures used in fermented dairy products. In the modern dairy industry, dairy starter cultures are prerequisite for the production of safe products of uniform quality. Lactic acid bacteria are often called dairy starter cultures, which are used for the production of various fermented milk products. These dairy starter cultures are carefully selected microorganisms, which are deliberately added to milk to initiate and carry out desired fermentation under controlled conditions in the production of fermented milk products. Most of them belong to lactic acid bacteria, like Lactococcus, Lactobacillus, Streptococcus, and Leuconostocs. In some cases, few non-lactic starters like bacteria, yeast, and molds are also used along with lactic acid bacteria during manufacturing of specific fermented milk products like kefir, kumis, and mold-ripened cheeses. Now the functions of starter cultures. Starter cultures can be used as single strains or mixed strains, depending upon the type of products to be prepared. The ability of dairy starter culture to perform its functions efficiently during manufacture of fermented dairy foods depends primarily on purity and activity of starter cultures. The major roles of dairy starter cultures are production of primarily lactic acid and few other organic acids such as formic acid and acetic acid. Coagulation of milk and changes in body and texture in final product. Production of flavoring compounds, example diacetyl, acetone and acetaldehyde. Help in ripening of cheeses by their enzymatic activities. Produce antibacterial substances in the finished product. In addition, they may possess functional properties. Now the nutritional and therapeutic value of fermented dairy products. From dietary point of view, some milk products like yogurt, dahi, acidophilus milk, kumis and other fermented milks are far more valuable than milk. During fermentation of milk, the composition of the minerals remains unchanged, while those of proteins, carbohydrates and vitamins and to some extent fat constituents change, which produce special physiological effects. The biochemical processes that make fermented milk products more nutritive than milk are proteolysis in milk. Proteolysis in milk plays by exo or endopeptidases of lactic acid bacteria. The biological value of protein increases significantly from 85.4 to 90%. This increase is due to breakdown of proteins into peptones, peptides and amino acids. The contents of essential amino acids such as leucine, isoleucine, methionine, phenylalanine, tyrosine, threonine, tryptophan and valine increases considerably, which offers special advantage not only to healthy people but also particularly to the physically weak persons. Fermented milks like yogurt, kefir, dahi are having higher protein digestibility due to precipitating into fine curd particles by lactic acid that contributes to their higher nutritional value and capacity to regenerate liver tissue. During fermentation and storage, the amount of free amino acids increases, particularly lysine, proline, cysteine, isoleucine, phenylalanine and arginine. Due to these biochemical chains in milk protein during fermentation, these products adopt a dietetic nature. Hydrolysis of lactose. Lactose in milk is hydrolyzed by metabolic activity of bacteria. Approximately 45 to 50% lactose, 16 to 20% galactose and 0.6 to 0.8% glucose are obtained from lactose hydrolysis on the basis of an average 5% lactose in milk. Lactose hydrolysis takes place due to beta-galactosidase production by lactic acid bacteria. The importance of lactose is due to lactic acid produced from the hydrolysis of lactose, which leads to a pH change in the bowel, inhibiting the growth of putrefactants. Now the change in vitamins. There is more than twofold increase in vitamins of B group, especially thiamine, riboflavin and nicotinamide as a result of biosynthetic process during milk fermentation. Now the antibacterial activities. The antibacterial properties of fermented milk products are determined by antibiotic activity of bacteria growing in the product. The antibiotic properties are generally associated with lactobacilli in yogurt, and compounds responsible for such antibacterial actions are lactic acid, hydrogen peroxide and other substances such as antibiotics and bacteriocins. Now the chains in minerals. In fact, there are not any significant chains in minerals in milk after or during fermentation process by lactic acid bacteria, and the nutritional values of fermented milk products remain intact. Now the therapeutic value of different fermented dairy products. Fermented milk products are well known for long life and cure-all properties due to their nutritional, therapeutic and prophylactic values. The main advantage of regular intake of fermented milk products such as yogurt, dahi, acidophilus milk, kefir, etc. are: number 1, these products are easily absorbed and better assimilated than sweet whole milk. Assimilation of milk is 32% in 1 hour, while that of fermented milk products is 90% in the same period. Number 2, they stimulate appetite due to their pleasant, refreshing and pungent taste. Number 3, These products also improve central nervous and respiratory system. Number 4. Gastric juice secreted by the action of fermented milk product and the desirable ratio of calcium and phosphorus leads to a high digestive capability. Next, they possess significant nutritional and prophylactic properties. Now, let us discuss about the production of different fermented dairy products. Cultured buttermilk. Buttermilk is the liquid left after butter making. However, cultured buttermilk is a fermented milk product made from pasteurized skim milk and low-fat milk in which mesophilic lactic acid bacteria is added as starter. Now its preparation. The starting ingredient of buttermilk is skim or low-fat milk. The milk is pasteurized at 82 to 88 degrees Celsius for 10 to 30 minutes. This heating process is done to destroy all naturally occurring bacteria and to denature the protein in order to minimize weighing off. The milk is then cooled to 22 degrees Celsius and starter cultures of desirable bacteria such as Lactococcus lactis, Lactococcus cremoris, Leuconostoc citrovorum and Leuconostoc dextranicum are added to develop buttermilk's acidity and unique flavor. These organisms are used in proper combination to obtain the desired flavor. The ripening process takes about 12 to 14 hours. At the correct stage of acid and flavor, the product is gently stirred to break the curd and is cooled to 7.2 degrees Celsius in order to stop fermentation. It is then packed and stored under refrigeration. Now the other product, that is butter or makhan. Butter is a fat-rich product obtained from cow or buffalo milk or a combination thereof, without the addition of any preservatives, including common salt, any added coloring matter or added flavoring agent. Now, butter preparation from ripened cream by lactic acid starter cultures. In this method of preparation, after pasteurization of cream, it's cooled to 15 to 21 degrees Celsius and inoculated with about 4% of mixed starter culture containing the acid producers Lactococcus lactis or Lactococcus cremoris and flavor producers like Leuconostoc cremoris or Leuconostoc dextranicum. The temperature of ripening depends on the season and may vary from 16 to 18 degrees Celsius in summer and 19 to 21 degrees Celsius in winter. Higher temperatures favor rapid ripening, while the lower levels result in easier cooling subsequently. The ripening process is always carried out in 2 or 3 states in order to facilitate the cooling of the highly viscous ripened cream. Cooling of the cream can be used to modify the hardness characteristics of the final butter. To produce a firm butter, following process is used. We cool the cream after pasteurization to 19 degrees Celsius and inoculate with the required amount of starter and hold at 19 degrees Celsius until the pH falls to 5.2. Then we cool it to 14 to 16 degrees Celsius and hold it for 2 hours. To produce soft butter, following process is used. Cream is cooled to 6 to 8 degrees centigrade after pasteurization. Inoculate with starter and hold for 2 to 3 hours to form an intensive crystal network in the fat. This stage aims to melt the small crystals and create a network of predominantly large crystals, and we hold it at 19 degrees Celsius until the pH falls to about 4.9. Then we cool it to 15 to 16 degrees Celsius. Before manufacturing, we cool it to churning temperature. A week's collection of butter is converted into ghee. Butter is used for direct consumption on bread and chapatis. It's also used for the preparation of Ayurvedic and Unani medicines. Butter is an important source of vitamins such as vitamin A, which is essential for good eyesight and vision. Now, another fermented product, that is yogurt. Yogurt is a semi-solid fermented milk product which originated centuries ago in Bulgaria. Its popularity has grown and is now consumed in almost all parts of the world, although the consistency, flavor, and aroma vary from one to another. The basic ingredients and manufacturing processes are consistent. Yogurt is strictly defined as a milk product produced by the action of two bacteria, Streptococcus thermophilus and Lactobacillus delbrueckii subspecies bulgaricus. In addition, yogurt may contain bifidobacteria and supplementary flora like Lactobacillus acidophilus for improving its therapeutic significance. Although milk of various animals has been used for yogurt production in various parts of the world, most of the industrialized yogurt production uses cow's milk. Whole milk, partially skim milk, or cream may be used. Now the preparation of yogurt. The milk is clarified and then standardized to achieve the desired fat content. The various ingredients are then blended together in a mixed tank equipped with a powder funnel and an agitation system. The mixture is then pasteurized for 30 minutes at 85 degrees Celsius or for 10 minutes at 95 degrees Celsius. The mix is then homogenized using pressures of about 2000 to 2500 psi before final heat treatment. Besides thoroughly mixing the ingredients, homogenization also prevents creaming and weighing off during incubation and storage. Stability, consistency, body and texture are enhanced by homogenization. After the final heat treatment, the mix is cooled to an optimum growth temperature and inoculated with the yogurt starter culture. A ratio of 1:1 of Streptococcus thermophilus and Lactobacillus bulgaricus inoculum is added to the jacketed fermentation tank. A temperature of about 42 degrees Celsius is maintained for 4 hours without agitation till the milk sets. This temperature is suitable for the two microorganisms. The titrable acidity is carefully monitored until the titrable acidity reaches 0.85 to 0.9%. At this time, chilled water is circulated in the jacket and agitation begins, both of which slow down the fermentation. The coagulated product is cooled to 5 to 22 degrees Celsius depending on the product. Fruit and flavor may be incorporated at this time and then packaged. The product is now cooled and stored at refrigeration temperature 5 degrees Celsius to slow down the physical, chemical and microbiological degradation. Another fermented product, that is cheese. A dairy product prepared from cow, goat, buffalo or sheep's milk that is set aside to thicken until it separates into liquid called whey and semisolids called curd. The whey is drained off and the curd is formed into the shape as per specification of cheese. It is packaged immediately, making it a fresh cheese like ricotta cheese or cottage cheese, or it is aged using various curing methods. There are almost 400 varieties of cheese, of which 18 are distinct. Now the technology involved in cheese making. Cheese manufacture is essentially a dehydration process in which the casein, fat and colloidal salts of milk are concentrated 6 to 12-fold with removal of 90% water of milk and almost all of the lactose, whey proteins and soluble milk salts. Concentration is achieved by coagulating the casein by enzyme modification, acidification to isoelectric point by starter culture or addition of acid, or acidification to pH 5.2 to 5.4 by starter or addition of acid and heating to 70 to 80 degrees Celsius. Concentration of the total colloidal phase of milk by ultrafiltration is now used commercially in the manufacture of a few varieties like feta and quark. Rennet cheeses are usually ripened after manufacture when the typical characteristics of the individual cheese develop. Acid cheeses are generally consumed fresh. All rennet cheeses are produced by a common mechanism. Now we'll discuss another fermented dairy product, that is kefir. Kefir is a traditional popular Middle Eastern milk beverage. It originated in the Caucasus Mountains in the former Soviet Union in Central Asia and has been consumed for thousands of years. It is the product of fermentation of milk with kefir grains and mother cultures prepared from grains. Kefir grains look like pieces of coral or small clumps of cauliflower, which contain a complex mixture of both bacteria, including various species of lactobacilli, lactococci, leuconostocs, and acetobacteria, and yeasts, both lactose fermenting and non-lactose fermenting, such that beneficial yeasts as well as friendly probiotic bacteria found in yogurt. Kefir grains or mother cultures from grains are added to different types of milk. It can be made from any type of milk, cow, goat or sheep, coconut, rice and soy, but commonly cow milk is used. The grains cause its fermentation that results in the production of various components in the kefir. Kefir is characterized by its distinct flavor typical of yeast and an effervescent effect felt in the mouth. The main products of kefir fermentation are lactic acid, ethanol and carbon dioxide, which confer this beverage viscosity, acidity and low alcohol content. Minor components can also be found including diacetyl, acetaldehyde, ethyl and amino acids, contributing to the flavor composition. This drink differs from other fermented dairy products because it is not the result of the metabolic activity of a single or a few microbial species. Now, the kefir production. There are three main ways of producing kefir: the artisanal process, the commercial process by Russian method, and the commercial process using pure cultures. Other substances may also be used, such as milk from other animal species, coconut milk, soybean milk, fruit juices, or sugar and molasses solutions. The traditional artisanal production method involves milk inoculation with a variable amount of grains and fermentation for a period of about 18 to 24 hours at 20 to 25 degrees Celsius. At the end of the fermentation process, the grains are sieved and can be used for a new fermentation or kept in fresh milk while the kefir beverage is stored at 40 degrees Celsius ready for consumption. While the kefir beverage is stored at 4 degrees Celsius and now is ready for consumption. The initial inoculum concentration of the grains affects the pH, viscosity, final lactose concentration and the microbiological profile of the final product. Agitation during fermentation also influences kefir microbial composition, favoring the development of Homo fermentative, lactococci and yeast. Incubation at temperatures above 30 degrees centigrade stimulates the growth of thermophilic lactic acid bacteria, while being a disadvantage for yeast growth and mesophilic lactic acid bacteria. The second method, known as the Russian method, allows for the production of kefir on a large scale and uses a process of fermentation in series, from the percolate resulting from the first fermentation of the grains. Different methods can be used in the industrial process of kefir production, but all based on the same principle. The milk is inoculated with pure cultures isolated from kefir grains and commercial cultures. The maturation phase can be performed or not, consisting of maintaining the kefir at 8 to 10 degrees Celsius for up to 24 hours to allow microorganisms, primarily yeast growth, contributing to the specific flavor of the product. Omission of this step is associated with development of a typical flavor in kefir. Now, the kumis. Kumis is another fermented dairy product traditionally made from mare's milk. Kumis is similar to kefir but is produced from a liquid starter culture in contrast to the solid kefir grains. Because mare's milk contains more sugars than cow's or goat's milk, when fermented, kumis has higher alcohol content compared to kefir. Even in the areas of the world where kumis is popular today, mare's milk remains a very limited commodity. Industrial scale production therefore generally uses cow's milk, which is richer in fat and protein but lower in lactose than the milk from a horse. Before fermentation, the cow milk is fortified in one of several ways. Sucrose may be added to allow a comparable fermentation. Now, the production of kumis. Kumis is made by fermenting raw unpasteurized mare's milk over the course of hours or days, often while stirring or churning. During the fermentation, lactobacilli bacteria acidify the milk and yeast turn it into a carbonated and mildly alcoholic beverage. Traditionally, this fermentation took place in horsehide containers, which might be left on the top of a door and turned over on occasion or strapped to a saddle and joggled around over the course of a day's riding. Today, a wooden vat or plastic barrel may be used in place of the leather container. Other accounts from some stees in northern or western China have it that the skin, partially filled with mare's milk, is hung at the door of each home during the season for making such beverages, and as passerby who are familiar with the practice give each such skin a good punch as they walk by, agitating the contents so they would turn into kumis rather than coagulate and spoil. In modern controlled production, the initial fermentation takes 2 to 5 hours at a temperature of about 27 degrees Celsius. This may be followed by a cooler aging period. The finished product contains 0.7 to 2.5% of alcohol. With this, we conclude today's lecture. Hope you have enjoyed and understood it. Thank you.